The purpose of this video is to demonstrate how multiple prediction intervals can be computed on the TI-83 and 84 calculators at the same time. This video goes along with Essay Exam 2 for the Acorn Range data set. And I realize that this particular essay or this particular data set and assignment require a number of prediction intervals, and there are quite a lot of calculations, so I thought I would show you how to do those all at one time on the calculator. So I've already entered the data into the calculator. I've defined list L1 as the X data values, or the acorn sizes, and list L2 as the Y values, or the ranges. And now, for this particular analysis, and I understand on this essay, there's part of the issue with the data are these severe leverage points, and one of the critical thinking components of this assignment is to try to figure out what to do about those leverage points. Now, they're clearly causing problems with the data set and the analysis. And for one of those leverage points, in a particular species of oak tree, I've given you a hint on an argument that can be made. That particular species only exists on islands, and so clearly its range is bounded, and so there's an anomaly in terms of the theory of larger animals carrying larger animals being interested in larger acorns, and therefore spreading those acorns further and creating a larger range for those species with the larger acorns. So that species is kind of bounded, and so that doesn't really fit with the theory. So it makes sense to throw that data value out. The other species of oak in question, the one with the largest X value, is a bit more of an anomaly. But one of the things that's interesting about that one is that it's the species of oak that Native Americans used as the fruit, or the acorn as food. And so, and that species also benefited from burning. Now, we know Native Americans definitely were into land management, and they definitely burned. They created fires, and they managed forests and wildlife populations even through that type of behavior. And so the question is, I think, did that human involvement with that species have an effect on its acorn size? And for me, this ties into an interesting theory I learned first about through reading Michael Pollan's Omnivore's Dilemma, where he speaks about the idea of coevolution, where plants increase the size of their fruit to entice humans to cultivate their species. And so I think an interesting kind of nuance here is whether or not that extremely large acorn for a relatively average kind of range here is another kind of an anomalous situation. So in any case, I don't know if that's the best argument that could be made to remove that other leverage point or not, but I just thought it was very interesting and a possible argument. And again, please keep in mind, I'm not looking for the one correct argument as to why that particular data value should stay in the analysis or go out. Mostly what I would like to see is the critical thinking in terms of what to do about this situation, where if first of all, to recognize that those are severe leverage points, and they're really affecting the fit of the model. In any case, that's not really the purpose of this video, though, to get into that kind of detail. And the purpose of this video is really to show you how to do the calculations. But I wanted to bring that up for a moment because I did pare the data set back from the original 11 to the 9 more consistent data values for the purposes of this video. So in any case, now here's the formula. for prediction intervals. And again, there is a language issue here because there are confidence intervals and there are prediction intervals. And what we're looking for here is a prediction interval. Now, I posted in Canvas a website that kind of gets into the differences between confidence intervals and prediction intervals. And I'll refrain from getting into that in this video as well, because I just really want to stick with the calculations here as much as possible. So what we have here is the formula, and then I also am giving you the pieces or the ingredients that go into that formula. So the first thing I want to talk about here a little bit is T star. Now that T star value is going to define the number of adjusted standard deviation units necessary for the specified level of confidence. And I'm doing all of these prediction intervals at a 95% level of confidence. So what we need is the 97.5th percentile of the t distribution with 7 degrees of freedom. Now the formula for degrees of freedom here is n minus 1, so the 7 comes from 9, which is the sample size, minus 2, which is 7. I think I said n minus 1, I meant n minus 2, okay? But in any case, degrees of freedom are n minus 2 here, so I have 9 minus 2, which is 7. Now the way we calculate this on the calculator is we go second, vars, that takes us to the distribution menu, and I'm going to choose inverse t. Just like inverse norm, inverse t gives us the specified percentile, that's the area, 97.5%, for a particular degrees of freedom, and that's 7 degrees of freedom for this example. I select paste it onto the home screen, then I press enter, and there is our T star value. And again, I've rounded this here, again, for convenience. 4 decimal places is more than sufficient accuracy. Now the S value comes from Lin-Reg t-test. So I'm going to go through how to do the Lin-Reg t-test for a couple of different reasons. But to do a Lin-Reg t-test, we go Stat, we arrow to Tests, and then we arrow down to Lin-Reg t-test. And the X list is L1, so I don't need to change that. Y list is L2. The theory here is that range increases as acorn size increases, so I'm choosing a greater than for the alternate. And then the regression equation. Now I need to archive this regression equation because we're going to need it to calculate y hat. So I'm going to go vars, I'm going to go y var, select y vars, select function, and then select y1. So what the calculator is going to do now is it's going to automatically store the equation of the line of best fit in y1. I'll come down here now and select calculate. We get all these different values again. There's our p-value. You will need to interpret that in your essay. There's a and the b. Those are the slope and the this is the y-coordinate of the y-intercept, the constant term, and the slope of the line of best fit. There's the coefficient of determination, so about 56% of the variation in range is explained by acorn size. And again, this goes way up, I think, after those leverage points are removed. So that's a real important piece of analysis in the essay, is to figure out what to do about that. And again, there's no right answer there. It's just a matter of thinking about it and making an argument. So here's the S, the standard deviation that we're going to need for the formula. This comes right from the Lin-Reg t-test. Okay, so I've written it down here for convenience. All right, so let's move along here and talk about some of the other pieces. Now, another piece that I need for the formula here is the mean, or X bar, the sample mean. Now, all the X values are in L1, so I can calculate the sample mean. There's a couple of different ways to do this, but the way I'm going to do it is I'm going to go second, stat, takes me to the list menu, and if I go over to math here, notice I can select mean. And this will calculate the mean of any data set, but I want X bar, so I'm going to calculate the mean of the X's. So I paste L1 in there, close the parentheses, press enter. So there's the mean, the sample mean, or the X bar, the sample mean for all of the X values, all the acorn sizes. Now another calculation I need to do here is the sum of every x value minus the mean, that quantity squared. So it's the sum of the squared differences between the x's and the sample mean. So the way we can do this on the calculator is go second stat, back to the list menu, and then back to math again, and there's sum. So I'll select sum. And we're going to take the sum of L1 minus, now I could just type this in, but I'm going to go ahead and go second stat, choose math, select mean again. I'm just going to have the calculator redo this calculation. Close the parentheses, put the square, press enter, and I get the wrong answer. What happened there? Second, I'm going to bring that formula back up. I typed something in wrong there. I'm going to go ahead and throw in an extra set of parentheses here. I didn't think these were necessary, but let me try this and see if this makes a difference. Okay, so there's my mistake. I thought the calculator would follow order of operations and do the exponentiation before the summing. Please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. But again, okay, so I'm glad this mistake happened. So that tells us that we definitely are going to need those parentheses for the sum. Okay, so in any case, there is the sum of all the x's minus their mean quantity squared. It's about 38.26. All right, so now the next thing we're going to do is we're going to calculate all the y hat values, okay? Now, if you look at the formula here, okay, the first value in the formula is y hat. And since we have 9 different species of oaks that we're creating prediction intervals for the ranges, there are going to be 9 different y hats. So what I'm going to do on the calculator is I'm just going to put all those y hats into one place on the calculator, L4. So I'm going to go back to the editor. I'm going to go Stat, choose Edit, and I'm going to scroll over here to L4. Okay. Now remember, when you're doing these list operations on the calculator, you need to have your cursor all the way up here on L4 on the very top. And notice the notation here makes a difference. So this means I have the whole list selected. If I arrow down one, I have L4 of 1, which means I only have that one cell in L4 selected. So here the calculator expects a single number. If I move my cursor back up, the calculator is expecting a whole set of numbers, and I want to put a whole set of numbers into the calculator. Okay, so y hat comes from the equation of the best fit line. I'm going to press enter and bring the cursor down to the formula bar. Now remember, I stored that, calculator automatically stored the equation for the line of best fit in y1. So if I go vars, yvars, function, and choose y1, and then say of second one for L1, paste L1 in, close the parentheses, what the calculator does when I press enter is it calculates all of the point estimates for each x value corresponding to each species of oak. So now I have the acorn size, I have the measured range, and then I have the predicted range. Now what we're going to do in L5 is we're going to put in all the lower limits of the prediction intervals. So I'm going to go one to the right, move my cursor up to select the whole list, press enter to enter a formula. So now we're going to go second 4 to paste in L4. And going back to the formula, so that's my y hats are all in L4. I'll do the lower limits first. So I'm going to do the subtraction first. I'm going to enter T star, so I put a parenthesis. My T star value is 2.3646. Close that parenthesis. And I'll put in the S value, which is 204.3713. Close parentheses. Second, x squared for square root. It's 1 plus 1 divided by n. Now n is 9, so that's 1 divided by 9. Plus, now this x represents all 9 x's in the data set. So each interval is going to have a different x value here. So when I enter this quantity, I'm going to put a parenthesis, and then I'm going to go second L1, and that puts in that's going to put in the whole list of x's. And we'll go subtract, and now I need second stat for list, back to math. I need the mean here again. So this is going to be the mean of L1. Close that parenthesis, another parenthesis, and then square. And then divide that by 38.26. That's the sum of all the x's minus x bars squared. So I'll type in 38.26. Arrow to the right to get out from under that square root, and then press enter. So what I've just calculated are all the lower limits for the prediction intervals for all 9 prediction intervals. Now we're going to do the similar thing in L6, but this time I'm going to do the plus to get the upper limits. So I'm going to, again, put my cursor all the way up here to the top, press enter. Second 4 for L4 plus T star, which is 2.3646, and S, which is 204.3713, close parentheses, second x squared, 1 plus 1 divided by 9 plus, same things, parentheses, second L1 for the x's, minus second stat math mean of L1, close parenthesis, square, almost there, divide by 38.26, right arrow, enter. Now we have all of the right boundary values, or right limits. So notice, if I put a comma between each of these numbers and parentheses on both sides, there are all 9 of the prediction intervals. Now I've also created a PDF document to go along with this video that I'll post in Canvas that further explains why these prediction intervals are necessary and some of the nuances. And again, I'll give you some ideas about how you might present this information in your essay. But the main idea with this course is not doing these really complex calculations as much as it is trying to understand what these things mean and how to interpret them and think critically about them. So I hope this video helps, and I'm looking forward to reading your essays. I'll see you next time.